So, good afternoon, everybody. I am Sharad Kumar from Secure Meters Limited, and as Ms. Leena Pandey rightly mentioned, that in today's scenario, advancement in technology in terms of energy management is the key requirement for not only the MSME sector, but other big size plants also. So, to start with, first of all, we have to understand what are the problems that are actually happening in the MSME sector, especially when we are talking about energy management. So the first part is the lack of adequate capital, where we have, on our behalf, we have conducted certain market research to find out what is the constraint to go for a very effective energy management solution. The first problem that actually arises is the lack of adequate capital. Now, what does it mean is that certainly just to implement any kind of a technology, we need to have a lot of capital, lot of money to implement such kind of a solution, which generally is not available with any small scale industry, a small scale plant. So the second part that comes as a bottleneck is the use of inefficient and obsolete technology. Now we generally used to see that in many plants, because generally in MSME sector we can see a lot of industry actually following the same kind of methods, same kind of I would say kind of things that which are useful for them, but quite traditional, quite conventional in their approach. So again, it is not effective for them just to get the maximum benefit of the present day technology and to upgrade their process altogether. The third problem, which generally keeps up, is the poor access to modern technology. Now, what we mean by this poor access to modern technology is because of the first two problems that we see in the MSME sector, because of the lack of adequate capital and the obsolete and old technology. The modern technology, the analytics is not available with the owner and the end users, so that they cannot maximize the efficiency of their process and get the maximum output in terms of energy saving. The fourth important part, which is the very crucial part, is the issues related to power. Generally, we see that there are different kind of tariffs available to the industry, and based on this scenario, again, there are certain issues with the power where we can see that there are power cuts, there are shortage of power, there are again open access schedule which is available. So again, when the power is not available in the correct forms, the MSME sector used to face a lot of challenge when it comes to fulfill the production requirement of their target. So I will jump directly to the issues related to power, because we are right now dealing with the energy management system. I will explain this in the coming slide. The first important point, which is the bottleneck, is the lack of awareness of daily power consumption. Now, what do we mean by this? Great scientist, Mr. Ford, once said that you cannot control anything, you cannot, justify anything if we are not able to measure anything. So if you are not measuring anything, we are not able to control anything, we are not able to say anything. So the daily power consumption awareness is not there with the end users in today's time, especially with the MSME sector. Second is there is no such kind of way just to find out when the maximum demand exceeded. We generally see that in any kind of a plant there is a sanctioned load, given to the end user, to the plant. And most of the times, because of the constraint due to the production pressure, certainly some plants actually used to exceed their maximum demand, which actually reflect into their energy bill. So again, it becomes quite crucial for them to understand how the maximum demand is actually treating the plant and what the benefit they can have by having a certain solution which can tell them when the maximum demand is overshooting or how my trend is actually going on in the complete plant's premises, so as to minimize such kind of overshooting bills. Now, in the absence of real-time information, the access to the open power facility is not even very effective. Many times, many of the participants here are quite aware of the open access mechanism where the electricity is available on a very reduced and a very subsidized tariff. Now, this is actually only applicable to through ABT, which is availability based tariff plan. And here, what is the requirement is that the end user will have to notify the state load dispatch center, SLDC or the RLDC, their 15 minutes consumption plan. Now for that plan, they need to have a very effective management solution, a very effective monitoring solution so that they can justify what they are going to bid for. So if I take an example of a plant, say 1 megawatt or an above, where the ABT plan is working, the engineer, the end user need to be very specific in terms of how much energy he is going for the complete day for a 24-hour schedule, or as per the depending on the state-wise rules and regulations. So at that point of time, 15-minute consumption plan or a half an hour consumption plan is a must for every end user or a plant. And in that scenario, if we don't have certain analytics, effective analytics, I would say, then certainly it become quite difficult for anybody to pinpoint the right amount of energy that they are looking for, and it may lead to the overconsumption or below consumption of energy despite whatever the bill that they are paying to the discoms. At the same time, if now many days we have seen that in most of the MSMEs, DG and solar power generation is again playing a very key role in the total production of the plant. Now, if we don't have again an integrated solution for these two areas also, again it will not help the management of the plant to ascertain what is the consumption through the mains, through the utility for the production, and what is the consumption through these auxiliaries, I would say, the DG and the solar power, and how actually we are utilizing the energy from these two areas. So again, these are the key areas, these are the key problem areas in terms of power, what the MSME sector is actually facing. Moving ahead, as we are talking about the energy management solution, I have used this term for more than, I would say, 20 times. Now, there are solutions available, there are softwares available in the market, the hardware and the software, where you can utilize such kind of mechanism. But again, they comes at a very high price, because we have seen that if the production of a plant is, say, suppose 10 lakh or 20 lakh units per annum, where the profit margin is around, like I would say 9 to 10 crores. I'm just taking a ballpark figure, I'm just assuming the values. So at that point of time, any company, any MSME inbound company will face difficulty in actually investing around 1 crore or 1.5 crore rupees for such a system. But here what we are proposing, the solution is what the name called is the eWatch online data services. Now, we are not talking about any kind of installation of any hardware or the software or the server kind of a thing. We are simply providing an online web-based solution for monitoring of energy consumptions, cost, operational efficiency, and system status. So altogether, if everything is available on a web portal, it becomes easier for the end user to effectively maximize the efficiency of the plant. It also enables the exchange of data from different utilities like electricity, gas, heat and water, and the live data from energy measuring points, which actually we have defined at the start, can be viewed in real time from any location with the internet access. Now we can uh, see more in detail. Now this eWatch online service that we are talking about as a solution is applicable to the industry, micro, small and medium enterprises. It is also applicable to the non-domestic commercial buildings like factory buildings, offices and institutions. Then it is also useful for the distributed generators and discrete loads where actually we can see the power consumption is there, and this whole data can be captured on the cloud. Now the software actually that we are talking about is, it will be helpful in creating a real-time personalized dashboards by measuring all the parameters. It will actually monitor all the parameters with respect to the shifts. It will be reporting the consumptions of energy, different energy groups. It will be configurable all the spreadsheets and whatever the reports that we are talking about. It will be helpful in facilitating the entry of production data. So every other aspect will be measured at one point, and with the help of an internet connection or through an Android based mobile phone, smartphone, the whole of the data can be seen at any instant. Now, by measurement, as we say that we cannot control anything if we are not able to measure anything. The first step that we have done with this kind of solution is that we have measured all the parameters which are the building block of any energy consumption profiling of a plant. Then we are monitoring it using advanced analytics, and then after that we are able to manage it. We are able to take control of what is required and what is not. Say by managing, I say that in this solution that I am talking about is we are able to put certain alarm systems for the threshold that we have set for certain specific parameters. We have also included different kind of alerts which can be helpful for the end user to get instantaneous notice if anything actually is going outside the decided trend. Now, going ahead, I would be talking about certain areas of the uh, software, the solution that we are talking about. It is the dashboard, where we will be able to see all the number of billing days, whatever the average consumption per day, and we can create the demand curve. So, if in a nutshell, if you try to find out, I will try to sum up all the benefits which can be taken out of this solution. Is that it will be helpful in creating awareness of the cost of all utilities, electricity, gas, heat and water, because there are different parameters which are working in different departments. So the all of the data can be taken from input output analog and can be fed into the system. We can isolate the waste and find out the actual efficiency of the system individually. We can set realistic targets for energy consumption. So as I said that the threshold can be set, and we can have alerts on unit time basis, whatever the time that has been decided by the end user. We can verify the effectiveness of the operational charges. We can monitor the performance of geographically distributed assets while on move as and when required. That means if certainly we have three plants, we have three premises at three different geographical locations. So the three different, different areas, different geography, the data can be purged into one system and can be seen by one end user sitting at a fourth geographical position, right? It will also enable and encourages active participation by managers and staff in terms of finding out the maximum efficiency possible for the uh, uh, plants. Now going ahead, this is the graphical view for the energy parameters. As I said that we have inculcated all the different possible areas where we can first of all measure the electricity supplied by the grid. We can measure the electricity supplied by the diesel generator, by the renewable resources, and whatever the electricity consumed against the total load or the feeder specific load which is ever applicable, and what is the running power factor and the demand. So these are the basic measurements that can be can be used against such kind of graph. And at the same time, when we are talking about monitoring now, this graphical view will also be a part of a monitoring where we can find out what is the energy consumption against the production, which generally we use by the name called specific energy consumption. We can find out the actual demand against contract demand. It can again be plotted using such kind of graphs. We can find out the target demand against open access schedule. As I said that the availability based area, the open access schedule is there. So whatever the target demand being set by the end user and what is the open access schedule, we can find out. What is the reactive energy against the load? It can also be plotted. The consumption of different type of loads or the energy can also be plotted. Location with high consumption areas can also be plotted with alerts. So it is again one of the key feature we are using such kind of graphs. Building energy consumption with respect to the temperature and humidity. Now this is a certain specific requirement that we come across while talking to many MSME sector owners while we were actually working on this solution. So they also told us that they are having certain problems while trying to maintain the production rate with respect to the minimizing the energy consumption and maintaining and measuring and monitoring the temperature and humidity. So this was one of the key feature where we are able to measure the energy consumption along with the temperature and humidity what is being defined by the end user. Consumption by the department or location using virtual groups. Now this is a key feature again. This is again a kind of a one step ahead to minimize the overall cost of the end user, where what we have done is that say there are four locations, four geographical locations, and we have to create fifth virtual location by the name saying all the DG consumption should be placed in that fifth location without putting any kind of hardware in the form of a meter, something like that. So a virtual group can be created on this software and the complete data for the DG consumption of all the plants will be there available on the fifth location. So you don't have to put money in terms of buying further more meters or the metering points. This is one of the part. Now the graph of historical consumption will also be helpful in finding out the key performance indices. Certainly, if you say that you have set certain goals for the production rate by day-to-day basis, so at that point of time, the analysis part can be done using such kind of historical consumption graphs, and we can also compare the consumption trends of different locations at one location. Now this is the open access data where we can see that the red line, if you say in this uh, graph, is basically that is basically the sanction load for the day. The green line is basically the target demand, and the blue line with the crest and troughs is basically the trend. So you can see that by using this kind of software, by using this kind of solution, we are able to analyze what is my trend for the complete day and how I am going to take benefit out of it. Now you can see at one point the trend actually overshoots the red line, which means that we have consumed over the sanctioned load for the day, and this will again incur us penalty. At the same time, in other areas, you will say there are gaps between the green line and the trend, which shows that the trend actually the demand actually being set for the complete day consumption is not up to the mark, and we have spent money more than what we have actually looked for. Going ahead, these are some of the tabular form you can see in the form of the table that you can see for the hourly basis we can generate. So there are different options which are available, and we can find out all the historical graphs and trends for all the areas. This is for the carbon footprint. It certainly many times we have seen that the industry is actually looking forward for carbon footprint and the carbon emission for the single day production. At the same time, there are certain areas in terms of the regulatory where they used to ask for the carbon emission generated against the total production. So again, this is one of the representation using graphs where we can see that how the carbon footprint is there for a single day. Now this is what we are talking about in terms of the Android application where the mobile application is there. There is nothing but a simple application which is available on the Play Store. Once all the hardware is actually installed on site, the next important thing that we need to do is to register the Skyline gateway, which will be helpful in communicating with the cloud-based system. Now, using these different areas, the consumption trend, the alerts, rating snapshot, the end user can find out what are the different happenings in terms of energy consumption in different areas. Say for example, I take the consumption trend here. Okay, so here you can see that it will once you put put the tab on it, there will be a location telling the metering point and the parameter that you want to look. It's a drill down scenario where you simply just push the tab there, and you will get different kind of parameters which are available with you on the Android application. You can choose that parameter, you can choose the daily consumption or the monthly consumption, and you can find out what is the trend for the consumption for that day. Now in this scenario, we are taking care of the active energy import for the total, and you can see that maximum for this month was also being mentioned here, because it is having a facility where one can store the data and can actually compare what was the maximum and minimum consumption for the month, if you say, if you want to compare. Now the reading snapshot is basically, say again, the location and the reading time, and whatever the parameters that you have chosen will be showcased there at one single uh, face. So all the parameters, the different voltages, phase wise, average voltage, and the active power, the reactive power, apparent power, active import, whatever the parameters that you have set for a specific metering point will be showcased at one single reading snapshot. Now, coming up to the architecture part, here what we are talking about is how the system used to work. You will see here that there are 4 different locations with the different multifunction meters, installed along with the gateway. Now, this gateway is basically having a data-enabled SIM card in it, and all the data, all the data will be pushed to the cloud internet by capturing the data from all the meter, and the end user is simply used to put a login credential, and he can see the data on the web portal or on the application. Now, before going ahead, as I am just discussing all the key areas of this kind of solution, certainly to everybody's surprise, it is quite important for you to understand that why you are listening to me. So I am just discussing one case study with you where actually we have given a maximum benefit to one such kind of end user. Basically, this was the deployment of energy management system at a sugar industry, and here the crushing capacity for that specific plant was around like 12,000 tons per day. Now, as a matter of fact, some facts for you for that plant was the generation capacity was 28 megawatt, and the plant load factor was 80%. Now, the monthly average plant consumption was approximately around like 7,500 megawatt hour, which actually excludes the auxiliary consumption of 10 to 15% of the total load. Now here, as you know, specifically about the sugar industry, there is one Central Electricity Regulatory Commission scheme, which is known as the Renewable Energy Certificate, and it is applicable to to the injection of energy 1 megawatt hour and above. So if certainly, say suppose we are injecting power of 10 megawatt hour, so it is equal to 10 renewable energy certificate, and every renewable energy certificate is costing around like 2,000 rupees, 2,000 Indian rupees. Now the company adopted this specific solution, and the benefit that this company got using such kind of solution was that because the energy generation using renewable resource. Now here I have forgot to mention that in sugar industry the byproduct is basically the bagasse, which most of the sugar industry owners use in the captive power generation plant to generate power, and using this solution they were able to measure the energy generation, and using such kind of solution they actually got around like a benefit of 75 million Indian rupees a year. Now, using such kind of solution, the sugar industry got the benefit using 3 ways. First is the simple export method, second was the wheeling, and the third was the banking facility. I can explain to you all the 3. First is the what is exporting active energy is that the generated power can be transmitted to the grid based on the total exported energy. Industry is paid for rupees 2,000 per megawatt hour of active energy exported. So this is again the simple export of the energy. At the same time, the wheeling is the other method where the process of generating power at one place and consuming it at some other place is called wheeling. In this case, the utility will only charge transmission charges for the units transmitted. For example, just to explain more about it is that if say you have 3 plants and you are having one CPP plant at one location, you can wheel the power and consume the energy at some other plant, and simply the utility will only be charging you the transmission charges. So again, it's again one of the benefit using this RAC scheme. And the other one is the banking facility, where this facility is basically useful for storing or banking the power at the peak hours, and this bank power can be stored as needed by the industry as and when, but not in the peak hour time. Now, going ahead, I'll give you certain inputs about us, that what who we are, how actually, because actually I'm just showcased you one case study from the sugar industry and how it can be helpful in your industry as well. We are the very first company in India who introduced the electronic metering concept back in the year 1987, when we simply started with 25 meters a day, and now we are simply manufacturing 16,000 meters and metering solutions a day. At that point of time, again, the employees were only 8, and right now we are more than 2,000 employees working, and we have different range of solutions with us, starting from the Kalmu technology based meter to the right now what we are talking about, the eWatch online data services and the prepayment system. The quick stats for our organization to share with you is that we have more than $415 million revenue as a company, and around we have more than 500 R&D engineers, one of the biggest R&D team for the metering solution globally. We have around 11 lakh prepayment meters installed all over the world, with around 16 lakh smart meters globally. So these are certain facts for you. And for any specific query, you can contact me with any inquiry, or whatever the technical queries there. We are always here to help you out. So we will be taking the queries now.
Yeah.